Good morning, everyone. I am Dr. Satish Kumar Gurupatham from Kansas State University, working as Associate Professor in Mechanical Engineering. So today's presentation is going to be on thermal image applications in estimation of fruit ripeness level and calculation of human body heat transfer coefficients. So this is how I have organized my presentation. So in introduction, I will briefly show how thermal imaging camera works and their applications. And then I will talk about the present works. Basically, we have taken two applications, and then I will explain the experimental setup that we used. Later, I will show the results we obtained, which will be followed by the conclusion. So thermal imaging camera works so in the following way. Any body which is above 0 Kelvin temperature emits radiation, which includes infrared energy. Because this infrared energy is not in the visible range, we are not able to see that through our normal eyes. And whereas a thermal imaging camera detects that energy and using a sensor, and it is converted into it basically undergoes some processing, and we obtain the image or video. So that's how it works. I have put it very simple way. So normally, as I said, now human eyes cannot see the infrared radiation, whereas some animals like rattlesnake, they can see that through their eyes, which are very helpful for them to hunt their prey. Basically, those prey will be visible even the night time. So it basically helps them to hunt their prey. And so the camera converts that infrared data into an electronic image that shows the apparent surface temperature of the object being measured. So in our current work, we are applying these thermal images to estimate the ripeness level of fruits non-invasively. And in the second work, we are showing how to measure the convective and radiative heat transfer coefficients of human body during a physical exercise. So when it comes to the fruits, even of the harvest of the fruits and vegetables, the metabolic activity continues for a while. And during that time, during that respiration process, as we see here, the sugar is oxidized and broken into carbon dioxide, water molecules, plus some energy. And this energy basically increases the fruit's temperature. And so for the fruits which do not change their skin color during the ripening process, such as kiwi and avocado, it's possible to determine the ripeness level using thermal images non-invasively. That's the goal of this first work. So we basically had the fruits which were fresh and damage free, and on continuous days of observation, we have taken the thermal images at the specific time and the constant time. So you can clearly see the thermal images showing the difference from the day 1 and day 4. So these are all avocados. You can see the change in their color and temperature. And this is for kiwi, and this is for peach. And so that's the whole idea. So through the thermal images, without making any damages to the fruit, we can estimate the fruit, the level of ripeness of these fruits. And it should definitely help the shelf life of the fruits. So here we are seeing the same information in the plots. So days versus temperature, and you can see that the temperatures going higher day by day during the ripening process. And in the second work, um, so we know that from the human body, heat is transferred to the surrounding, especially when we are doing some physical exercise. So that heat transfer rate is higher, and these are the different modes of heat transfer: conduction, convection, radiation, and evaporation. And you can see that a big chunk is coming from convection and radiation. And the thermal imaging technique is used to calculate convective and radiative heat transfer coefficients for forehead, arms, hands, and legs of two different age groups and sex. So basically, we had four batches, each containing a male, female, um, below 20 age, above 20 age, and they were allowed to run on a treadmill. As we see here, this is the treadmill we used, and this is the thermal imaging camera, and we also measured the humidity in the room. So basically, they were allowed to run on the treadmill for 20 minutes. So before they started running, we took the thermal images, and during the running, also after they have run, we took the thermal images. You can see that the temperature, surprisingly, initially it drops, and then it goes up for all the body parts. So that can be explained because um, though the muscles contract and generate the heat after the running has begun, it takes some time for the muscles to become hotter than the core temperature to transfer the generated heat. So it basically takes some time for achieving the temperature gradient. So when the exercise continues, the muscles are hotter enough to transfer the heat to the core. As a result, the skin temperature increases. That's the reason we have the initial decrease in the temperature of those parts. So we basically use these two models. The first one is Wenger's PMV model, which is a popular one for calculating the heat transfer coefficient, and where TB is the body temperature and TS is the surrounding temperature. And for the radiation model, we took it from the ASHRAE handbook. And so this is emissivity and AR over AD. I'm going to show that in the next page. And this is the average body surface emissivity. E is the surface emissivity, and this is AD is the Du Bois body surface area, and AR is the effective radiation area of the human body, and TB is average closed body surface temperature, and TS is the room temperature. And these are the results we obtained from the observation. So, we can see that the measured convective heat transfer coefficient is very close with the literature values, and so the minimum variation, maximum variation, and average variation we have calculated for all the body parts for both the age groups, and this is radiative heat transfer coefficient. And so I'm going to go ahead with the conclusions. The temperature of the fruits were found to increase during their ripening process. This is due to the heat generation during the extended respiration process after the harvest. The ripeness level of the fruits, which do not change their skin color during the ripening process, such as kiwi and avocado, can be found using thermal images non-invasively. It would help minimizing the wastage of fruits by estimating their shelf life. And in the second study, the thermography was applied for calculating the radiative and convective heat transfer coefficient for two age groups and two different sexes. The results were very close with the literature values, The convective heat transfer coefficient of the hand, 3.785, was found to be the closest one with the literature in the above 40 age group. The maximum variation being 0.858 watt per meter square per Kelvin for convective heat transfer coefficient was observed from the literature values for all the body parts. Okay, so that's it. I try to finish it as quick as possible. So let me know if you have any questions. Thank you.